You should really replace your brake pads today. They're almost worn out. For safety's sake, don't wait. If you drive, chances are you've heard something exactly like this before. You're likely standing in the brightly lit waiting area, or perhaps you've been escorted into the cavernous, echoing bay of the repair shop. The smell of aerosol brake cleaner and old oil hangs in the air, and the service advisor is holding a clipboard or a tablet, their expression carefully composed into one of grave concern. And in that moment, you're stuck in a dilemma. Refuse, and you risk catastrophic brake failure and a potential accident. Agree, and you might end up spending a few hundred or even a few $1,000s unnecessarily, all because your brake pads might still have 40% of their usable life left. Today, we're going to break down one of the most commonly used, highly effective tactics in auto repair shops, the safety scare. With a simple $5 tool, you can measure your brake pad thickness in under 10 seconds and shut down any shady upselling on the spot. Brake systems are undeniably critical. There's absolutely no argument there. But precisely because safety is priceless, it's also the easiest area for shops to manipulate. When a mechanic shines a high-lumen LED flashlight into the dark, grimy recesses of your wheel well and tells you there's barely anything left, your brain immediately shifts into a primal fear mode. Rational thinking goes out the window, replaced by terrifying mental images of your car failing to stop at a busy intersection. But what does barely anything actually mean in mechanical terms? A brand new brake pad is typically about 10 to 12 milliliter thick. To visualize that, it is roughly the thickness of a modern smartphone wrapped in a heavy-duty protective case. The actual safety limit, the point where structural integrity and heat dissipation begin to genuinely compromise braking performance, is usually around 2 to 3 millimeters, which is about the thickness of 2 standard pennies stacked together. Yet, many mechanics will recommend an immediate replacement when pads are still sitting comfortably at 5 millimeters. That is roughly half their usable life, meaning you could still drive another 10,000 to 20,000 however kilometers safely under normal commuting conditions. They're betting on one powerful universal thing, that you won't dare gamble with your life or the lives of your passengers over a few millimeters of composite material. Today, we're replacing vague fear with precise, undeniable data. Why we give in so easily? This isn't just about cars and metal components. It's a masterclass in psychology. Picture the setting. Your car is lifted high overhead on a hydraulic hoist, its underbelly exposed. You're standing off to the side, completely out of your element. The mechanic is dressed in a branded uniform, holding heavy pneumatic tools, speaking confidently in technical jargon and pointing at dusty, grease-covered parts you rarely, if ever, look at. Words and phrases like severe wear could fail anytime, and especially dangerous at highway speeds, start piling up in the conversation. In that highly structured environment, the power dynamic is entirely asymmetrical. Most people just say yes, because compared to parting with your hard-earned money, the sheer paralyzing fear of what if something happens on the highway feels far worse. This is what we call the safety fear trap. In that moment of transaction, you're not actually buying brake pads, steel, or labor. You're buying an emotional state. You're purchasing peace of mind. But peace of mind shouldn't come from a place of information asymmetry. It should come from facts. Understanding how brakes actually work. To break this cycle of dependency, you need to deeply understand the mechanical system at play. Imagine you're driving at a 100-kilometer rate on an open stretch of road and suddenly hit a wall of gridlocked traffic. You instinctively slam your foot on the brake pedal. That simple, half-second human action activates an immensely powerful, beautifully engineered hydraulic system. Your foot pressure pushes a steel rod into a brake booster, which uses the engine's vacuum pressure to multiply your leg strength. This amplified force pushes a piston inside the master cylinder, forcing specialized, non-compressible hydraulic brake fluid through an intricate network of rigid steel lines and reinforced rubber hoses running to each wheel. When that fluid reaches the wheel, the intense hydraulic pressure forces heavy steel pistons inside the brake calipers to instantly extend. These pistons clamp the brake pads aggressively onto the spinning cast iron brake disc, also known as the rotor. The resulting friction is violent. It converts your car's forward kinetic energy into massive amounts of thermal energy, heat, sometimes pushing the temperature of the rotors to over 200 degrees, slowing the massive weight of the vehicle down to a smooth halt. In this brutal process of friction and heat, the brake pad acts much like a heavy-duty eraser being dragged against coarse sandpaper. It is designed to be sacrificial. It gradually wears down, shedding microscopic particles of metal, resin, and ceramic. That fine black dust you see constantly accumulating on your silver alloy wheels, that isn't dirt from the road. That's your brake pads literally turning into powder over thousands of miles. This wear is completely normal. It is the system functioning exactly as engineers intended. Now here's a highly revealing question. The last time you paid a shop to replace your brake pads, did you actually hold and inspect the old ones, or were they quickly tossed into a greasy scrap bin before you ever had a chance to verify their condition? If you didn't see them, there's a very high probability you've already overpaid for a brake job at least once in your driving life. The optical illusion trick. Many drivers think they can just peer through the spokes of their alloy wheels to judge pad thickness. That visual ambiguity is exactly what less scrupulous mechanics rely on. There are two main structural reasons this purely visual inspection fails. One, you're not seeing the full material. Brake pads are not a single solid block. They consist of a thick, rigid metal backing plate, usually painted black or gray, and the highly engineered friction material bonded to the top of it. Many people, even seasoned drivers, confuse the thick steel backing plate for the friction material itself, or they only catch a glimpse of the beveled edges. High-quality brake pads are often manufactured with chamfered, angled edges to reduce vibration and braking noise. Because the edges slope downward, the pad looks significantly thinner at the top than it actually is in the thick, flat center where it contacts the rotor. A mechanic shining a bright, focused beam of light at just the right oblique angle can cast shadows across these chamfers, making a perfectly healthy, thick pad look dangerously thin to the untrained eye. 2. Limited viewing angle. The massive metal structure of the brake caliper completely wraps around and blocks most of the pad from view. You're only ever seeing a tiny, recessed edge through a narrow, dark gap between the wheel spokes. Without a proper physical reference point, the human eye is entirely incapable of accurately distinguishing between a safe 6mm and a dangerous 3mm, especially under the poor, shadowy lighting conditions of a wheel well. The brake fluid trick. Here's another highly common, visually deceptive tactic used in the service bay. As your brake pads naturally wear down and become thinner over months of driving, the heavy steel caliper pistons have to extend further out of their housings to push the thinner pads against the rotor. Because the pistons are taking up more physical space inside the caliper, they draw hydraulic fluid down from the master cylinder reservoir under your hood to fill that empty space. This causes the fluid level in the translucent plastic reservoir to visibly drop. This is a closed system, and this displacement is 100% normal physics. But some shops will pop the hood, point dramatically to the lowered fluid level sitting near the mine line, and say, "Your brake fluid is almost totally gone." That means your pads are completely worn down to the metal, or worse, you might have a dangerous hydraulic leak. This rapid-fire chain of worst-case scenarios is designed to mentally overwhelm you, bypass your critical thinking, and push you into immediate, expensive action. The $5 tool that changes everything. The absolute best way to fight vague, fear-based claims is with cold, precise measurement. Enter the brake pad thickness gauge. This simple, low-tech tool is a mechanical truth teller, often shaped like a pocket knife or a keychain. It requires no batteries, no calibration, and no technical training. It consists of a set of durable metal blades stamped in different thicknesses, intuitively color-coded like a traffic light. Green blades, 8 to 12 mm. Excellent condition. The pads have plenty of thick, robust friction material left. Yellow blades, 4-6 mm. Mid-life. You're entering the second half of the pad's lifespan. Braking is perfectly safe, but you should keep an eye on it during your next oil change. Red blades, 2-3 meters, time to replace. The friction material is critically low. When the thin red blade is the only one that fits snugly between the backing plate and the rotor, that's your definitive signal to spend the money. Not a moment before. How to check it yourself. No wheel removal needed. You don't need to be a grease-covered mechanic, and you don't even need a jack. Park your car on flat, level ground and engage the parking brake. Start the engine and turn the steering wheel completely to one side. This pivots the front wheel outward, heavily exposing the heavy metal brake caliper behind the spokes. Turn the engine off. Get down near the tire and use your phone's flashlight to illuminate the gap inside the caliper where the brake pad sits against the shiny, flat brake rotor. Take your thickness gauge and insert the colored blades through the wheel spokes, testing the different thicknesses in the narrow gap between the pad's metal backing plate and the rotor surface. Find the specific blade that slides in snugly without being forced. That blade represents your actual, undeniable pad thickness. If the angle is awkward or visibility is poor, simply use your phone camera with the flash turned on. Zoom in, record a short video of the gap, and review the footage clearly on your screen. Once you've physically done it once, the mystery vanishes, and it becomes surprisingly easy. Your built-in warning system, the squealer. Automotive engineers are well aware that most drivers don't inspect their cars regularly. Because of this, modern cars already come equipped with a brilliant built-in acoustic alert system. The mechanical wear indicator, commonly known in the industry as a squealer. It's a very small, aggressively curved metal tab riveted directly to the backing plate of the brake pad. It sits exactly 2 millimeters above the absolute bottom of the friction material. When the pad gradually wears down to that specific 2 centimeters threshold, The exposed metal tab finally makes physical contact with the rapidly spinning cast iron rotor. This metal-on-metal friction produces a highly distinct, sharp, high-pitched squealing or chirping sound that changes as you drive. That grating sound isn't a catastrophic mechanical failure. It's an engineered warning. Think of it exactly like the beeping of a microwave or a smoke detector. Your brake pads have reached the end of their life cycle. Please schedule a replacement. If you're not hearing that high-pitched metallic chirp with your windows down and your car's braking performance still feels firm, smooth, and responsive under your foot, your pads are highly likely to still be in safe, working condition. The rotor upsell trap. Even if you legitimately need new pads and agree to the service, the psychological upselling rarely stops there. You will almost invariably hear the following pitch. Your rotors are heavily grooved and glazed. If you don't pay to replace them, or at least have us machine and resurface them, your brand new brake pads will wear out incredibly fast, and your braking will feel unstable and jerky. It sounds mechanically logical to the layperson, but it's very often highly exaggerated. Rotors are massive, durable discs of heavy cast iron. Minor surface grooves, light scoring, and a tiny lip on the outer edge are completely normal byproducts of friction. When you install new flat brake pads against a slightly grooved used rotor, the new pads will naturally bed in. The high heat and pressure will cause the new composite material to mold and match the specific microscopic topography of the old rotor surface within just a few hundred kilometers of normal city driving. Rotors generally only necessitate an expensive replacement if they meet very specific failure criteria. The overall thickness of the solid iron disc has worn down below the manufacturer's strict minimum specification, which is permanently stamped directly onto the hub of the rotor. There is a severe, noticeable pulsing vibration felt deeply in the steering wheel or brake pedal when applying the brakes at highway speeds, indicating the rotor has warped due to extreme heat cycles. Deep structural cracks are visibly radiating outward toward the edges of the metal. If none of these serious symptoms apply to your vehicle, there's absolutely no mechanical need to replace that heavy iron hardware. Car maintenance is, at its core, a business. Generating a profit is normal and expected, but that profit shouldn't be extracted from a foundation of fear and intentional misinformation. Brake systems aren't as fragile or mysterious as they're often made out to be in the service lane. Their wear is incredibly predictable, entirely physical, and easily measurable. From now on, don't walk into a brightly lit repair shop as an uninformed, easy target. Remember the raw data. Brand new pads sit at 10 plus millimeters. The actual replacement threshold is 2 or 3 millimore. Rely on physical evidence, use a $5 metal gauge, or trust the acoustic warning of the squealer. Knowledge strips away the anxiety and puts you firmly back in control of your vehicle and your wallet. Next time a service advisor looks at you with grave concern and tells you your brakes are dangerously thin, just reach into your pocket, take out your gauge, and calmly tell them you'd like to measure it yourself. Watch closely how quickly the entire tone of the conversation changes.